All right, now that we've talked about solubility and solubility, let's do the opposite and talk about precipitation. Okay, this is module 3.2. So bottom line is, you can say that everything dissolves in everything else, but to what extent does it dissolve? Okay, and so our rule of thumb is going to be that if the solubility limit is less than about 0.01 molar, we're going to consider this to be insoluble. Okay, so now there are certain rules that chemists over the years have come up with to try to predict solubilities of different substances or compounds. So what I'll do is I'll show you what these solubility rules are. So these solubility rules are really more like solubility guidelines because there are some exceptions, but I want to point them out to you here. Okay, and so first off, all nitrate, acetate, perchlorate ion compounds guaranteed to dissolve in water, okay, have to be soluble, as well as if you have anything with a group 1A or alkali metal ion. So these are things like lithium, sodium, potassium, rubidium, cesium, as well as ammonium. Okay, so if you see any of those things present, those are guaranteed to dissolve in water. Most halides containing chlorine, bromine, or iodine salts, these are also probably going to be soluble, but there are some exceptions. Okay, and so here's where it gets a little interesting. Things like lead and silver and dimercury are not soluble. In other words, if you had something like NaCl, sodium chloride, okay, that would dissolve in water. But if you had something like AgCl, silver chloride, that does not dissolve in water. Okay. Most sulfate salts are also soluble. But the exceptions here are a lot of these divalent ions, like strontium, barium, lead, and our friend dimercury again. Calcium is slightly soluble. It's kind of on the border of soluble and insoluble. And then, once you think you understand the rules, they change. Okay, most of these are insoluble, meaning that they tend to form precipitates. So the things that are insoluble include carbonates, hydroxides, phosphates, and sulfite salts. The exceptions, of course, are anything with group 1 metal ions. So the ones that we talked about earlier, lithium, sodium, potassium, rubidium, cesium, and ammonium. Okay, all of these things will dissolve, but in general, they don't, unless it's one of these. Calcium, barium, and strontium are, again, borderline cases, slightly soluble. Okay, so when you're talking about chemical reactions, if you're not part of the solution, you're part of the precipitate. Ah, get it? See, funny? Okay, never mind. All right. In these reactions, which are called ionic equations or ionic reactions, okay, things that dissolve or dissociate break apart into ions. Things that don't stay together as one thing. That's the precipitate. Okay, let me give an example. Let's say that you wrote down a chemical reaction between silver nitrate, AgNO3, and sodium chloride, NaCl. You would expect these things to react with each other, kind of a double replacement reaction, to make AgCl, silver chloride, and sodium nitrate. This is what I'm calling my overall reaction. Okay, this shows you everything. But if you could zoom in and see what these little things look like in solution, they kind of break apart and dissociate, right? So the silver nitrate would really form silver ions and nitrate ions. And the sodium chloride would form sodium ions and chloride ions. So they're going to dissociate completely. Ag plus, NO3 minus, Na plus, Cl minus. The AgCl is a precipitate. This doesn't dissolve, stays together. So I'm going to keep it AgCl. Sodium nitrate, according to solubility rules, should also dissolve in water. So this is going to form sodium ions and nitrate ions. And so this is what I'm going to call my ionic equation because it shows all the different ions in there. But if you notice something interesting happens, okay, Na plus shows up here and here, so I can cancel it out, as does nitrate here and here. So the things that I'm crossing out, like the sodium ion and the nitrate ions, these are called spectator ions. Right? They're there, but they're not actually doing anything. They're kind of like spectators at a sporting event. Right? They're there to cheer you on, in this case, make sure that things are balanced and neutral, but they're not really doing anything as far as the chemical reaction is concerned. So the ones that are actually doing something are the ones that remain. This is the net ionic equation. And so in this case, the net ionic equation is a reaction between silver ions and chloride ions to make AgCl solid that precipitates.